आज हम लोग इलेक्ट्रिक चार्ज और उसकी प्रॉपर्टीज़ के बारे में देखेंगे कि इलेक्ट्रिक चार्जेज होते क्या हैं, कैसे एग्जिस्ट करते हैं, इनके एप्लीकेशंस क्या क्या हैं, इनको कहाँ पे यूज करते हैं और कौन से ऐसे डेली लाइफ सिचुएशंस हैं जहाँ पे हमें चार्जेज दिखाई देते हैं। सबसे पहला एक वर्ड है इलेक्ट्रोस्टैट्स। Electrostats refers to the electric charges at rest. So in the electrostats we have to study about the electric charges, their behavior, their properties, their uses when the charges are at the rest. So first we will try to see what is a charge. As we know that all the materials are made up of electron, proton, neutron. All the materials consist of atom and the atoms are consist of electron, proton and neutron. And we know that only the electrons can be transferred from one body to another body. And inside an atom, number of electrons and number of protons both are equal. So an atom is electrically neutral. We can see here, this is the atom of material 1 and this is the atom of material 2. Here the number of protons and number of neutrons, whatever is there, they are confined inside the nucleus. The electrons are found in the orbit. So the electrons from the outermost orbit can be transferred from one atom to the another atom. So when an atom loses an electron, it becomes positively charged, and when an atom receives the electron, it becomes negatively charged. In the similar manner, we need some methods so that the transfer of electron can take place and a material can be charged. So if we look about the charge, so what is the charge? Charge is the property. Charge is the property of all the materials by virtue of which it can exert the force of attraction or force of repulsion on another body. Often you would have seen when a comb is rubbed on a dry hair, and when this rubbed comb is brought near to the small piece of papers, so the paper pieces are attracted towards the comb. Why it happens so? Because due to the rubbing, the comb becomes charged. Comb becomes charged, it means there happens the transfer of electrons from the comb to the hair. In this process, the comb becomes charged and hair as well. When this comb is brought near the piece of papers, the papers are attracted. Now you see, the transfer of electrons only can take place. Due to the transfer of electrons, the material which loses the electron become positively charged and the material which gains the electron become negatively charged. So how much charge a material can hold? Since there happens the transfer of electrons and an electron carry 1.6 into 10 to the power minus 19 Coulomb charge. Coulomb is the SI unit of the charge. In the CGS unit, we use electrostatic unit or stat coulomb. 1 Coulomb is equals to 3 into 10 to the power 9 electrostatic unit. So generally we will deal with the coulombs because we refer to the SI system. There is another unit in the CGS system EMU, electromagnetic unit, or F coulomb. Electromagnetic unit or F coulomb. 1 coulomb is 1/10th part of EMU. So, when a material loses 1 electron, then it will be charged by 1e positively, and if a material gains 1 electron, then it will gain negative charge of 1e. Now here we can see there are the two materials A and B. Material A is donating the electron, means electron is transferred from material A to material B. Electron is transferred from material A to material B. If there is only transfer of 1 electron, so the material A will gain 1e charge, material B will gain minus 1e charge. Similarly, if the material A loses 2 electrons, so material A will gain plus 2e charge and material B will gain minus 2e charge. It means the charge acquired on a body is equal to the number of electrons transferred from one body to another body. Charge acquired on a body is equal to the number of electrons multiplied by elementary charge. This is known as quantization. This is known as quantization. Quantization, this is the property of a charged body. And in the quantization, we say that quanta means packet. Every time there happens a transfer of packets filled with the integral multiple of number of electrons. Quanta means packet, and this is the packet made up of number of electrons. So if there happens only 1 electron which gets transferred from one body to another, so the charge will be plus 1e or minus 1e. If there take place the transfer of 2 electrons, so the charge will be plus 2e or minus 2e. The positive and negative nature of the charges, this depends on that which material donates the electron and which material receives the electron. The material that donates the electron loses the electron, become positively charged, and material that receives the electron become negative charge. Thus, if we see that charge on a body is always integral multiple 1e or 2e or 3e, only this is. We cannot have the charge on a body 1.5e. This is not possible. Because 1.5, this is the number of electron, and the number can never be in the fraction. Number of electrons will be always in the integers. So if somewhere it is shown that Q equals to 1.5e, so this is not possible because n can never be in the fractions. However, we can say charge can be 1.5 coulomb. Now just you notice the difference in these two. Here the charge I am saying Q equals to 1.5e. E is the elementary value, charge on an electron, and 1.5 is here a number. The number cannot be in the decimal, number cannot be in the fraction. So this is not possible. And Q equals to 1.5 coulomb. This is not the number, this is the amount of charge which is possible. Now you will say how it is possible. So here we have, if we have Q equals to NE and Q equals to 1.5 coulomb, The number will be here the integer because value of elementary charge is 1.6 into 10 to the power minus 19 coulomb. Now, to find the value of n, we can see 1.5 divided by 1.6 into 10 to the power minus 19. This will result 1.5 upon 1.6 into 10 to the power 19. Now, this is 15 by 16 into 10 to the power 19. Now, if we see the value of n is now an integer, 15 by 16 into 10 to the power 19 is an integer. So, do remember these 2 points. If you have been given Q equals to 1.5 E and Q equals to 1.5 coulomb, so this is not correct, not possible, whereas this is correct. Here, if the charge is the multiple of E, so it should be the integral multiple, and 1.5 is not the integer. Whereas 1.5 coulomb, this is the absolute charge on a body which can be held on a body. So, if we speak about the properties of the charges, so the first property comes out here as a quantization of charges. Once again, I am repeating and note it down. The first property of the charge is quantization. In the quantization, as I told, quanta means packet. So quantization refers to the packaging of elementary charge. So charge on a body is always an integral multiple of elementary charge. Charges can never be in the fractional multiple or decimal multiple of E. Charges always exist in the form of Q equals to plus minus n into E. N is some integer. This property is known as quantization. Now if we speak some another property of a charge, so we can see here another property, and this is the very basic property, and this also comes in the fundamental rules of the universe, conservation of charges. In the conservation of charges, here we have taken two materials A and B. Here there are few protons and the few neutrons which are confined inside the nucleus in both the materials A and B. Suppose that there are 8 electrons and 8 protons. So this atom, this material A is electrically neutral and initial charge on this body is 0. Similarly, if on the body B, assume that there are 5 electrons and 5 protons, so charge on body B is also 0. Number of negative charges and number of positive charges both are equal. So this material is also electrically neutral. So taking the system of both the bodies A and B, if we find the total charge Q1 plus Q2, so we will find 0. Now by some methods, by some techniques, we manage to transfer the electron from body A to body B. After transferring the electron, the situation that comes here is shown in the diagram. This body A has lost one electron, and now the number of electrons is 7, whereas the number of proton is as well as in the beginning, same, it is 8. Since the body B has gained the electron, this is the body B, has gained the electron. Initially there were 5 electrons and now there are 6 electrons. The number of protons as well 5 was in the initial, 5 this time. So here the body B has one more electron, so charge on the body B is minus 1e, and body A has lose some electron, so one electron if it has lose, so charge on the body A is 1e. Now taking A and B both as a system, we see that Q1 dash plus Q2 dash means charge on body A plus charge on body B after transfer of electron or after charging is again 0. It means in a system of A and B, the initial charge is 0 and the final charge is 0. It refers that charges on a system, on a body, always conserve. Charge can never be created, charge can never be destroyed, only the charges can be transferred, and more precisely if I see, the electrons can be transferred from one body to another body to make the body charged. Until and unless there is a transfer of electron, a body cannot be said to be a charged body. So, second property of the charge, that charge is on an isolated system. Isolated word I am using because I am not transferring charge, I am not taking charge, I am not giving the charge from any external agent. So A and B are making an isolated system. The transfer takes place from A to B or vice versa. So the total charge remains conserved and constant. If we see the third property, it will be additive nature. Additive nature means if on a body there is a charge of 2 coulomb, minus 5 coulomb and 7 coulomb. So the total charge on the body by the additive nature, the total charge on the body Q equals to Q1 plus Q2 plus Q3 plus Q4 and so on. So here on this body the total charge will be plus 4 coulomb. So basically now there are the three properties of the charge. Quantization. Quantization means the charges always exist in a packets of, or I should say more precisely discrete packets of E. Charge on a body is an integral multiple of elementary charge E. Second, conservative nature of the charges. Charges on an isolated system are always conserved. The charges can never be destroyed nor it can be created. The third, additive nature. The charges can be added algebraically. If on a body there are many charges, so the total charge will be the algebraic sum of the charges present in that body. Now the key points of this discussion, that remember you would be given a charge under root 2e. You would be given Q equals to under root 2e. Now just you think yourself whether this charge is possible or not. Now you are given Q equals to under root 2 coulomb. Again now you have been given Q equals to 4 coulomb and you have been given Q equals to under root 4 coulomb. Now use your idea to identify out of these four which one is correct and which one is not correct, that is which one is not possible. So here Q is in the form of integral multiple of E. This is not an integer. Root 2 is not an integer. So this is not possible. Under root 2 coulomb this is not in the terms of the multiple of E. This is the total absolute charge on a body which is possible. Q equals to 4 coulomb, always correct. Q equals to root 4. If I say root 4 E, now this is in the terms of multiple of E. Just to check, this charge is represented in the terms of multiple of E, whether this multiple, this coefficient is an integer or not. So root 4 is an integer, and so we can write 2E. So this is also correct, only the incorrect part this is. Now let's see how we can charge a body. And before this, if I say you to find number of electrons and protons in 90 gram of water, the question is find the number of negative charges and positive charges, or find the number of electrons and protons in 90 gram water. So what should be the approach? The first you think the approach how you will find. First of all, 90 gram of water you need to convert into the number of moles. Then, using Avogadro number, find the number of molecules. Then, in one molecule, how many electrons and protons are there? So you will be able to find. Now let's approach. First, number of moles. This is 90 gram divided by 18, because H2O molar mass is 2 plus 16 equals to 18 gram molar mass. So here it comes 5 moles. Now how many? First step is now fulfilled. Second, how many molecules are there? Number of molecules. So equals to 5 moles of water. You have the number of molecules into Avogadro number, that is 5 into 6.022 into 10 to the power 23, that is molecules we have. Now let's find H2O, third step. In H2O, there are 2 atoms of hydrogen and 1 atom of oxygen. So in hydrogen, there are 1 proton and 1 electron. In oxygen, there are 8 protons and 8 electrons. Thus, in one molecule, of H2O, 2 protons from the hydrogen atom and 8 protons from the oxygen, that is 10 proton, and 2 electrons from hydrogen atom and 8 electrons from oxygen, that is 8 electrons. So in one molecule of H2O we have the 10 protons and 10 electrons, and the total number of molecules we have 30 into 30.110 into 10 to the power 23 molecules. So total number of protons equals to 10 into 30.110 into 10 to the power 23, and the same number we have the number of electrons. So thus these are the few basic things. If you have been asked find the number of protons, number of electrons in 1 cup of water, so estimate that 1 cup of water contains 90 gram water, 150 gram water, 200 gram water, and then find the number of moles. Multiplying the number of moles with Avogadro number, find the number of molecules, and now just you calculate in one molecule how many electrons and the protons do you have. Had it been NaCl, common salt, in place of H2O, so here the number in one molecule, the number of electrons and the number of protons will be changed. There had been, if NaCl, so sodium atomic number is 11, so there are 11 proton and 11 electron. Chlorine atomic number 17, so there are 17 proton and 17 electron. So one molecule have 28 protons and 28 electrons. In this way we can find the number of negative charges and positive charges in a given substance. The second part now I can raise that how much in the previous question 90 gram water, how many proton and electrons were there. Now the question can be changed. What is the total negative charge in 90 gram of water? So had it been asked what is the total charge in 90 gram of water, so we will follow the same procedure and find the number of electrons. So this is the number of electrons, 10 into 30.110 into 10 to the power 23. So if this is the number of electron, 300.110 into 10 to the power 23. Now the total charge Q equals to N into E, and Q equals to 300.110 into 10 to the power 23 into value of E, elementary charge 1.6 into 10 to the power minus 19 coulomb. So we can find the number of total negative charge or the number of negative charge in a given substance. Now let's see how we can charge a body. For charging a body, there are mainly three methods: by friction, that is by rubbing, by induction, and by conduction. By friction or by rubbing, when we rub two materials, so there happens the transfer of electron from one body to another. In this way, one body become negatively charged, another body become positively charged. Most common phenomena you would have noticed that when a comb is rubbed on a dry hair, it gets charged. After charging, it starts attracting the paper pieces. By induction, when a charged body is brought near the another uncharged body, so that uncharged body also becomes charged by the process of induction. Means when a charged body is brought near another uncharged body, then another body also gets charged. There is no mutual contact between these two bodies. There is no mutual transfer of electron between these two bodies. In spite of that, the another body gets charged. This phenomena is called induction or electrostatic induction. Third method is by conduction. When a charged body is brought in contact to another body, then another body also gets charged, and this is known as charging by conduction. We will discuss the charging by friction or by rubbing, charging by induction and charging by conduction in the next unit. By then, thank you.